Hello class, so this is the third video that I want to prepare for you. So this is an equivalent force kind of problem. As you see here, we have the we have the forces here in the drawing. We have two cords, ropes with tension attached at this point here, and you have a weight that is hanging from it. So what we're looking for here is what is the value of tension in cable T2, what is the tension in cable supporting the weight, so the bottom cable, and what is the gravitational force acting on the ball. So there's a bunch of stuff that we have to find in here. So let's draw the free body diagram. For if you want, you can look at this point right in the middle of the where all the chords connect right here. So for that point right there, we have a force of tension that is on an angle. Let's make it more closer to 30. So an angle something like this. So that would be your T2. You have T1 is directly to the left, and you have the weight or the force of gravity that is being applied downwards. Okay, so at that point in there, we can look at the forces that we provide, or write some equations. If you have something on an angle, always break it up into its components. So in this case, I'm going to have the x and y components of this force. So the x component is going to be right there, which is going to be opposite to T2. Okay, so that's going to be T2 x, and we're going to have another T2 component that is going up, and that's going to be T2 y. This is an equilibrant for problem, so we don't have any motion in this system or in this drawing, so we're assuming that everything is stationary. There's no acceleration, since nothing is indicates that. In this case, that means in the x direction, so if you want to write the Fnet x, that is going to be T2x minus T2, so minus T1, it would be 1 right here, and Fg is going to be equal to T2y. So we can look at that later on. So Fnet in both x and y direction are going to be 0. Okay, because there is no motion, there is no acceleration, they're at rest, so they're going to be equal to 0. So we can say that T2x equals T1 and T2x equals to T2 times the x component here is going to be the opposite, which is sine 30. Now we are only provided with T1, so that would actually allow us to find T2, because we know T1 and we know sine 30 what we don't know is T2. So we can find T2. So that will provide us the answer for A. T2 equals T1 divided by sine 30. So in all of these problems, you always have to draw a free body diagram and try to see if you can find information from there. But that is very important, finding Fnet x and Fnet y in every scenario. So T1 is 30 Newton divided by sine 30. And when we do this, 30 divided by sine 30, and that was 60 newtons. So that T2 is equal to 60 newtons. In the direction, so you can say 30 degrees from 30 degrees up from the vertical. So we want to see direction, and it's the upward direction. Up from the vertical. Okay, let's find what is the tension in cable supporting the weight. So if you're looking at the weight, so this one here is slightly, I guess, different. If you want to look at the free body diagram for the weight, so you have Fg is down and the tension is up. So let's call that T3. So what do you think the force is acting on that rope? It is going to be Fg, opposite to Fg, so Fg up. So if we're looking at that problem separately, we're going to do Fnet, and that's only in the y direction. There's no x direction in there. Fnet y for the weight, let's put W here at the bottom. Fnet y for the weight is equal to T3 is up, you can say minus Fg, or the weight. So, and that is Fnet is going to be 0, because again, no motion, no acceleration. So that would be T3 equals Fg, which equals, which we do not know at the moment actually. That would be Fg, we know T2y is Fg actually from the previous drawing. Fg if you look at the first free body diagram, we already found that Fg is opposite to T2y, or you can say Ft2y as well. So T2y, which will provide us with some numbers here. T2y is 60 newtons times cosine 30 degrees, and that will be 51.96 or 52.0 newtons. Now T2y is up, so that's going to be positive, or we can say the tension supporting the weight is going to be also moving up as well. T3, I'm going to just say up. That looks different. So just say up. Finally, we're looking for C. C is more of a concept kind of question. So for C, they're looking for what is the gravitational force acting on the ball itself. So we're looking for Fg, and that would be the same as the tension, but a different direction. So Fg equals 52.0 newtons down. So you can see that simply by just looking at the either of the free body diagrams that we did for the ball, or the original free body diagram that describes the whole scenario. That's it.